Okay, class, in section 6.2, we're looking at graphs of exponential functions. So the characteristics of a graph of the parent function, f of x to the b of x, right? So an exponential function of the form f of x bx, so remember our exponent, our variable is in the exponent, with b greater than 0, so our base is greater than 0, and b is not equal to 1, has these characteristics. So first, it's going to be a one-to-one function, okay? It's going to have an horizontal asymptote at y equals 0. So that's here. That's our horizontal asymptote. It will have a domain of negative infinity to infinity. And a range, because of that asymptote, is going to be from 0 to infinity. So our range, as we look here, is going to go from 0 to infinity. But as we look at that domain will go from negative infinity to infinity. X-intercepts, none, because again, we have that horizontal asymptote there. Our y-intercepts, it will intercept at 0, 1, right here. It's increasing if b is greater than 1. But if b is less than 1, right, then it's not increasing. It's actually going to be decreasing. So if that base is negative, we're going to be looking at a decreasing function. Figure 3 compares the graphs of exponential growth and decay functions. So I do want to say something here because this isn't super clear. So I want to actually go ahead on your paper and let's scratch this and change it to 0 is less than 1, which is less than, oops, sorry, I did that backwards, b, which is less than 1. It should actually match this over here because we're basically saying that our base is a function. We don't want negative values. We really do want to stick to the fact that our b has to be positive, because if you think about it, if our b is negative, right, if we got to be negative, like negative 1, right, and I have the x value here, what happens? So what ends up happening is we end up with an oscillating function, because when x equals 1 on my function, right, at 1 I'm going to equal negative 1. Right, so I'm going to be right here. But at 2, I'm going to be positive 1, so I'll be up here. And at 3, I'm going to be negative 1. So it's kind of going like this. It's going to be going like this because of that negative there. So we really want to keep that base positive so that it follows these characteristics. So let's change that. Let's make sure we're really saying 0 is less than b, which is less than 1. Okay, which is exactly what we're seeing here. All right, let's look at the first example. We're going to graph 4x. What is A, the domain, B, the range, and C, intercepts that we may have? Okay, so if our base is 4, let's first kind of look at this from a function, a chart function perspective. Here's our x, here's our f of x. Okay, so if I plug in 0 here, 4 to the 0 power is going to give me 1. If I plug in 1, I'm going to get 4. If I plug in 2, well, now that's 4 to the second power, which is going to give me 16. Okay, so you can see I'm going to start getting higher there. So let's plot some of these. So at 0, I'm going to be at 1. When x equals 1, I'm going to be at 4. But when x equals 2, I'm going to be all the way up here, like in 16. Okay. What happens if I plug in a negative number? If I plug in negative 1, notice that this would be 4 to the negative 1 power, which is equal to 1/4. So that's even less than this. So here we're going to be here. Okay, and if I wanted to plug in negative 2, you'll see, well, that's the same thing, same 4 to the negative 2, which is the same as 1/16, right? So we start seeing the reciprocal. So it's going to be even closer to that. Okay, so we will see, again, our domain here doesn't change. Our domain will be negative infinity to infinity. Our range will be, so notice our b is greater, so then our range is just going to be from 0 to infinity. And any asymptotes. So our asymptote, right, is just like before. Asymptote is at y equals 0. That's our horizontal asymptote. So we're going to see our horizontal asymptote here. Okay. And let's go ahead and draw this function here. So our function is going to go really close to that asymptote here. It's going to go through our values, and then it's going to kind of jump off into infinity. Okay, so our graph is going to look something like that. And we don't have to go all the way off the graph, like we can kind of stop here. I just want to mention, we're trying to really get to that 16 there. Okay, and so those are all the things that we were asked to do for that question. All right, let's take a look at this one. Actually, try this one. Plot a couple points first, and then I'm going to go ahead and discuss it. So go ahead and start with x and f of x. All right, this was what you got? So I decided to choose -2, and the reason why I decided to choose -2 first is I really want this top, that exponent, to kind of equal 0. And so I know that it'll equal 0 when I plug in -1, but I wanted to go ahead and try 1 before that. So when I plug in -2 here, I'm going to get 2 to the -2 plus 1. That really gives me 2 to the -1, which is 1/2 minus 3. And actually, so that means I made a mistake here. This should be 2.5. So this would be -2.5. Okay. So now let's take a look at the next one. So if I plug in -1, I'm going to get 0. 2 to the 0 is 1. So I'm going to get 1 minus 3, which gives me that -2. So now when I plug in 0, I am going to get 2 to the +1, which is 2. 2 minus 3 gives me -1. And if I plug in 1, we get 2 to the 2 minus 3, which gives me that +1. And then that 5. So now we can go ahead and plot these values onto our graph here. So let's go ahead and plot a couple of these. So at 0, I'm going to be at -1 here. At -1, I'm going to be at -2. Okay. At 1, I'm going to be at +1. Okay. At 2, I'm going to be at 5. There we go. Okay. So we can tell that there is a shift here, right? Notice that thinking about our horizontal and vertical shifts, this whole thing shifted to the left by 1, right? But it shifted downward by 3. Right, so notice that we went from here, we're going down 1, 2, 3. All right, and we shifted over. So you see that the third one would be here. So now that's kind of shifted over, which is telling me that our asymptote, right, if our original asymptote is 0, because we're shifting downward 3, this new asymptote is going to be located at y equals -3. And so to see if this is true or not, all right, let's plug in another value and see if we can get lower than -3. So in this particular case, let's see if we pick, let's say -10, just to try it out. So here we would have 2 to the -10th power plus 1 minus 3. This is going to be 2 to the -9 minus 3. Let's come over here to the calculator. So 2 raised to the -9 power. And then we are going to subtract 3. Right? So notice that's -2.99999. So that's definitely telling me that there's going to be an asymptote here at -3. So, which makes sense based off the transformation of the function. All right, so let's take a look. Now let's answer some of these questions here. So the domain here, our domain A, is still going to be -infinity to infinity. But now B, for the range, our range, right, we got a little bit lower than the last one because of that asymptote. So we're actually coming lower. So our range is going to go from -3 to infinity. But we're going to make sure that we open up that parenthesis because we're not including that 3. And lastly, C, we talked about how that y horizontal asymptote is actually getting shifted downward 3, so we end up with y equals -3. And that's it for that problem. Our last problem in this section is going to be f of x equals 4x minus 2 plus 3. Thinking about the way we just did the last one, try this one out and give yourself a second and then go ahead and check it. All right, class, so you should have tried this problem. Notice I plugged in a couple different values here. I plugged in 0, 1, 2. I can start seeing kind of what's happening here with the 3. And notice because this is an upward shift of 3, this is going to shift that asymptote. So if that original asymptote is at 0, because I have a vertical shift of 3, my asymptote is going to be shifted up 3. So that's how I get the c equals y equals 3. So because that asymptote is shifted upward, and we can kind of see this here on the graph, that means that my range is also going to be affected, because now my range is going to go from 3 to infinity because of that upward shift. But my domain stays the same. So my domain is still going to be negative infinity to infinity. So we can see how all these shifts kind of come into play with this graph. All right, I wanted to take a moment to show you how to graph this on a graphing calculator because as much as I want you to understand how to graph it manually, realistically speaking, you're going to be graphing on a calculator. So in the Desmos calculator, you know, I'm here at the Desmos graphing calculator. I'm just going to go ahead and plug in the values. All right, so our function is f of x equals 4x minus 2 plus 3. So we're going to do y equals 4 raised to the x minus, oops, forgot my parentheses, open parentheses, x minus 2, close parentheses, and then we're going to add it to 3. And so notice that's our graph. Notice if I graph y equals 3, we'll make this a dotted line. Settings, here we go. I'm going to make this a dotted line, hit done. And so we can see that there's our our horizontal asymptote. And if I were to zoom in here, it's hard to tell because it looks like it's really like touching it. But if we zoom in close enough, you'll see that our function is really, really close, but it's really not touching that horizontal asymptote. All right, that's the end of this problem. And that's how you graph them.